For my final project, I wrote some Python scripts that would generate a map that would color code precincts in a Arlington County election that happened last November based on whether John Weisstadt or Alan Howes won the precinct. And I was interested in this because it was an important election in our area. John Weisstadt won the election, and this was the first time he was not a Democrat. The Democratic candidate was Alan Howes, and this was the first time that a non-Democrat had won a county council election in Arlington in a county council general election since 1983. So it was a very significant election, and the issue that drove the election that most analysts say was the proposed streetcar. There was a streetcar proposed to be built along Columbia Pike, which is the main east-west corridor in Arlington, Virginia. And there had been years of planning that had gone into this, and it was in the late stages of planning, and they were preparing to move toward implementation. And a very active campaign was created to oppose the streetcar. John Weisstadt ran primarily, I think, on that issue, being opposed to the streetcar. That was the issue that everyone was talking about. Alan Howes was in favor, and he was opposed. So he won the election. And when I was looking at the election results earlier on, I noticed that it looked like that in areas near Columbia Pike, precincts that would have been most impacted by the streetcar, Howes actually won. But in those areas further away, Weisstadt won. So I wanted to see if I could make a map that would show that. And I set about to learn, through this class, the tools that I would need to do that. And I was going to need two different data sets in order to make that happen. And the first data set would be the election results. And searching for the election results, I found that the Virginia Department of Elections actually has a website that's pretty easy to use, and you can select year, select election, and then there are results for those elections in a comma-separated value, or CSV file. So this link right here, you click on this and it will download the CSV file. So the first thing I needed to do was to download that file and then parse the data and figure out extract the data that I needed. So let me minimize this, and let's take a look at that part of it first. So here I am. I'm going to change into the data directory. This file 1104/2014_complete is the CSV file that has the data. And I'll take a quick look at that. I had never actually dealt with comma-separated value files before. I had heard of them a lot, but I had never parsed one or tried to get data from one. So this was a first experience for me doing that. And a little bit of research, and I found out that the first line, I already knew that in comma-separated value files, you have each row is a data item, and the fields are separated by commas usually, and that's why they're called comma-separated values. The first row is special in that it has the names of the fields rather than data. So in this case, we can see that this first row here, we've got election name, election date, locality name, locality code, and so forth. And finally, way down here, we've got candidate name and party, and then total votes. So, and then the other one that I was going to be interested in was the precinct, which is this field over here, precinct code. So I was going to make use of that because I was going to, in the shape file that I'll be looking at later, precincts have codes that correspond with this precinct number, basically, here. So if we go to the bottom of this file, we can see that it has 37,816 records. Or I guess one less than that, because the first one is the field names. But that's for precincts all over the state of Virginia, and I'm only interested in Arlington and the Howes-Weisstadt election. So my first thing I was going to have to do was to parse that and get out the data that I wanted. I wrote a script, which we'll take a look at now, called Precinct Winners. And doing a little bit of research, I found out that Python has a built-in module for dealing with comma-separated values, and it's appropriately named CSV, and it's part of the standard library. So I was able to just import CSV, and Python is just so much fun to use. It really is a wonderful language, and this was surprisingly easy, or maybe not surprisingly easy to use. So what it did, it has a dict reader, and let's take a quick tour of this actually. So I import CSV. I created two constants here, one for each of the names of the two candidates, so that I could just refer to them as candidate 1 and candidate 2. And then what I did here was I was going to process the data. I pass in the name of the file that I'm going to process, which is the file we looked at just a moment ago. And then I open it as CSV file. And then I read in using csv.dictReader I create a reader. And what that does is create actually a dictionary that has all of the fields that we saw in the first row together with values from all of the other rows. So you read in all of the data by field. And so now what I'm going to do is I'm going to go through each record, and I'm going to check to see whether the candidate name is one of the two candidates that I'm looking for, candidate 1 or candidate 2, Hals or Weisstadt. And if it is, then I'm going to extract the name of the candidate, the precinct number, which is precinct code, and the total votes. And then I'm going to create my own little dictionary which I started out with an empty dictionary here, and now I'm going to check whether this is the first time I've seen that precinct, if I've seen it before, and if I've seen the precinct before, in which case it'll be in results, then what I'll do is I will just set add a new record, a new key rather, to the dictionary, and with a candidate set to that number of votes. And then if I've already seen it, then all I'll do is assign that candidate, the other candidate's votes, to that same record. So it may be more illustrative to see this. At this point I'm only returning winners, but Python is very easy to modify. So let's change this program a little bit so that it returns both winners and results, so we can look at both of those. And that's going to require a little change down here also. So I could just say winners, comma, results, gets process data. And now I can, if I run this, you see this is what it's doing now. It's returning just the list of a list containing the names of each of the winners in the 52 precincts in order. And in order not to have to use an offset, I set the first one to none, so that in precinct 1 it's in position 1 in the list, and Alan Howells won that one, and in precinct 2 you can see John Weisstadt won. But before that, let's change this around a little bit, and instead of displaying winners, let's display results so we can see what that looks like. And when I run this, we can take a quick look at what that's building. It builds a dictionary. So here is the first, the dictionary has keys, which are the precinct numbers, and the value of each of those are another dictionary that has the name of the candidate as a key, and the value being the number of votes they got. So in this case right here, we can see that the first item in our dictionary has a key of 42. It's a string, 42, and the value is John Weisstadt 399 and Alan Howells 412. So that gives you an idea of how that data works. So I'm actually going to change it back the way it was now, so we'll just return winners here. return just winners here also, because that's really all I needed this to do. And now it's back to just, it'll print out. If I run it as a program, it prints out as well as returning the value of this list. So this list is what I needed. So now I've taken the CSV data, I've parsed it, I found the candidates that I was looking for, I identified each precinct in Arlington, I stored their votes, and then the thing that the list, it generates the list by, basically I pass in a precinct, and I compare the precincts, the tallies for candidate 1 and candidate 2, and return the candidate who got the larger vote. So that then is appended to the list, and I end up with a list of names in the order of precincts as to who won. All right, so that's parsing the CSV data. Now the next thing I needed to do, and I had actually started this earlier with a number of experiments because I had never dealt with shape files before either, and in the book that we all used for this class this semester, we learned to use Mapnik to make maps, and I have a couple of before I show you the one that produces the final project, I did a number of experiments. So the first experiment was to draw precincts, and I wrote this script right here, and I found, let me bring up the web browser again, 2 sources of data that I was going to use here. Arlington County makes a lot of GIS data available now through their website for this purpose. And the 2 pieces of data I was going to use for this project are the precinct maps, and this is a shape file that has the outlines of all 52 precincts in the county. And since my original intention was to draw Columbia Pike on the map, I found another data set, another shape file that had the roads in it. And that turned out, as we'll see in a little bit, not to work the way I anticipated that it would. So I had to make some modifications on that. But it did have the roads in the county. So this script right here uses imports Mapnik. It sets the shape file to be the voter precinct shape file. And then it creates a set of rules to set the background color to what I did was I colored the precincts with this light reddish color, and I made the outlines here using stroke black, and then I created a layer, set the background to this sort of light green here, and then told it to render the map. So if we run this, over here you can see a list of the files that are here right now, and if I run this make precinct map, a map will appear, and you see it being rendered right here. And when I open that, bring it into view, this is a map of the 52 precincts in Arlington County. So that was one of the first experiments that I did with that. And now my final project involved 2 more things. I was going to try to color code these, and I was going to actually then try to draw Columbia Pike on the map. Now, drawing Columbia Pike turned out to be a problem. So here's another script that opens the roads file, the roads database, which we can see right here, roads, the shape file that has the roads in it. And it renders each of the roads. If you run this script, it will draw all the roads that are in this file. And here it's producing a map there. I color-coded them orange. And here we have all of the roads in Arlington County. So I did this first, and I said, oh, look, I've got the roads. And I assume when I actually wrote some other scripts to explore the shapefile, count the number of records, and there were 883, and I mistakenly thought, oh, that refers to 883 different roads, and all I have to do is find the one that represents Columbia Pike. Well, it turned out it doesn't really work that way. Each of the 883 geometric objects in the shapefile, they were polygons, I guess polylines, and they really referred to a set of road segments that were contiguous. So, and they didn't correspond at all to individual roads. So to illustrate that, here is another script I wrote that draws a single one of those road shapes. And I'm going to open up this map here. And so this was after I played around a little bit. This right here is one of the shapes that are in that roads file. And it does have a little piece of Columbia Pike on it right here. This border right here is where Columbia Pike runs. And it does have Columbia Pike, but it also has little pieces of adjacent road segments that run off of Columbia Pike. So once I figured out that was how that worked, and when I was looking at the roads shapefile, I noticed that there was really no metadata that had road names, and I was wondering why. And once I investigated that, I figured out why, because they're not really names of roads, they're just little different pieces of the road. So what I did finally was to decide, all right, well, I'm not going to be able to really illustrate Columbia Pike at this point like I want to. That's something I hope to do later, in a different way, using maybe OpenStreetMap data. But in the meantime, I'll just find the little pieces of road clusters that lie along and near Columbia Pike, and I'll print those. And I used a brute force process of elimination to do that. I actually would render half of them and see if they had Columbia Pike pieces in it, and then render the other half. And through a rather tedious process of elimination, I created a list right here of all those segments that had parts of Columbia Pike on them. So of the 883, these are segments that lie along or near Columbia Pike. And so this map does two things. I'm going to draw the precincts like I did before, but this time I'm going to color code them. And the line that color codes them, after setting up some constants for color, so here's green and here's red, and I chose green and red because green for go and red for stop on the streetcar was what I was thinking. And then the line that I used to set the color was this. So I set the color to green if winners of the precinct equals house, and otherwise I set it to red. And I read that in, because I'm using the precinct winners here, so I have candidate 1 and candidate 2, and Weisstadt was candidate 1. It's actually just reading in here the string John E. Weisstadt, spelled exactly right, and Howes is Alan E. Howes here, read in from that other file that I showed you earlier. And so it then it determines green or red for the winner of the precinct, and then it renders the precinct polygons in that color and puts a black border around them. And then I also, down here in this section of code, I make another layer. So this was the first time I used 2 layers, and that was rewarding to know that I could apply these layers. Look forward to doing more with that later. But this then takes pieces of Columbia Pike that I found and then renders them in orange. And as you'll see in a moment when I run this, the color contrast is not ideal, but for now I'm going to leave it the way it is, and I'm going to try to work on getting OpenStreetMap data to just render Columbia Pike. But I'm going to go ahead and run this script now, and if we look over here, we'll see the map, the final map that I produced appear. And here it comes, and this is the map. And so it's got three things going on. We have green precincts where Alan Howells won, red precincts where John Weisstadt won, and then we have little pieces of road segments along or near Columbia Pike. So my original hypothesis seems to be confirmed, that you can see that even though Weisstadt won the vast majority of the precincts, the ones along Columbia Pike tended to be won by Howells. In fact, he won 8 of the 10 that have the most, that are most near Columbia Pike. So that was my project, and I'm excited about the ability to draw maps like this, and look forward to doing a lot more things with this.